Hello everyone, today I want to make this video to talk about some interesting encryption techniques used in IT. Encryption is the process of taking a message and scrambling its contents so that only certain people can read it. There are two types of encryption, symmetric and asymmetric encryption. Let's first take a look at symmetric encryption to understand why asymmetric encryption was created. This is the simplest kind of encryption that involves only one secret key to cipher and decipher the information. It uses a secret key that can either be a number, a word, or a string of random letters. The sender and the recipient should know the secret key that is used to encrypt and decrypt all the messages. Blowfish, AES, RC4, DS, are examples of symmetric encryption. The most widely used symmetric algorithm is AES 128. AES 192, and AES 256. For instance, I have a sensitive document that I want to share with John. I use an encryption program to protect my document with a password. Then I send the encrypted document to John. However, John cannot open this message because he doesn't know the passphrase that I used to encrypt the document. In other words, he doesn't have the key to open the lock. Now comes a real problem. How can I share this passphrase securely with John? Sending it through email is risky because others might find the passphrase and use it to decrypt any messages between me and John. This is exactly the kind of problem that asymmetric encryption intends to solve. It's comparable to a mailbox on the street. The mailbox is exposed to anyone who knows its location. We can say that the location of the mailbox is completely public. Anyone who knows the address can go to the mailbox and drop in a letter. However, only the owner of the mailbox has a key to open it up and read the messages. Let's go back to technical details. When using asymmetric encryption, both me and John have to generate a key pair on our computers. A popular and secure way for doing this is by using the RSA algorithm. This algorithm will generate a public and private key that is mathematically linked to each other. Public keys can be used to encrypt data, and only the matching private key can be used to decrypt it. Let's now take a look at how we can use asymmetric encryption to communicate securely with each other. We start by exchanging our public keys. John gives his public key to me and I give my public key to John. Now I can send my sensitive document again. I take the document and encrypt it with John's public key. I then send the file to John, who uses his private key to unlock the document and read it. Because they use asymmetric encryption, only John is able to decrypt the message. Not even I can decrypt it because I don't have John's private key. If an attacker steals my private key, it can be used to decrypt all messages that are intended for me. However, the attacker cannot decrypt messages where sent by me because that requires John's private key. And the next important thing to understand is, asymmetric encryption algorithms take way longer than symmetric encryption algorithms. So people often use symmetric encryption to encrypt large amounts of data and files, then encrypt the symmetric key with asymmetric encryption and send that encrypted key together with the encrypted file. Asymmetric encryption is used in a lot of places where security really matters. You might not be aware of it, but every time you visit a secure website via HTTPS, it makes your data transmission secure by encrypting the traffic using asymmetric encryption between the client and the server. Moreover, it's also being used to securely send emails with a PGP protocol. And one last example, Bitcoin also uses asymmetric encryption to make sure that only the owner of a money wallet can withdraw or transfer money from it. Another popular way to secure data information is using hash function hashing. It is the process of converting an input of any length, for example letters, numbers, and symbols, using a mathematical function then produce an output of a specific length. The message is to be hashed. It is called input. The algorithm used to do so is hash function and the output is called hash value. There are many formulas that can be used to hash such as MD2, CRC32, SHA-512, SHA-1, and MD5. All of them need to have some qualities to be considered useful. The same content runs through the same hash function will always produce the same output. Just like humans have fingerprints that are unique to each individual. The hash speed is also an important factor. The hash function needs to quickly produce the hash value. Finally, the hash function needs to be secure. The hash cannot be converted back into the original key. A slight change to a piece of content will result in a whole new hash to represent it. Hashing is widely used for many security purposes. Password storage can be considered a typical example. For any account, you have to use password to verify that you are the account's owner. However, if the password is stored as a text, it somehow can be stolen by hackers, and this is really a big problem. So, the server wants your password to let you in, but it doesn't want to store it. This is where hashing comes in. The server just needs to store the hash value's password by any formula to confirm it is the right password anytime users log in. There is no way to convert back the original password by the hash value, so it is extremely secure. Encryption is a two-dimensional technique, including encryption and decryption. You can encode a text into a random string. Then you decode again to read and retrieve the information in it by using the proper key. The main idea of encryption is to protect data from an unauthorized person who wants to read or get information from a message that was not intended for them. In contrast, hashes are only one way. Hashing cannot reverse the process from hashing to original data. Hashing can be used to compare a large amount of data. Hash values can be created for different data, meaning that it is easier comparing hashes than the data itself. In conclusion, what would happen if encryption is banned worldwide? Without encryption, all your personal information, banking accounts and all data on anything accessible through the internet would be considered public. Without encryption, every message transmitted can be understood. All radio communications become public. Without encryption, the wireless world collapses. The internet world barely survives and might as well abandon the idea of using connected computers. Without encryption, electronic businesses would most likely collapse, and so would the economy. Thanks for watching.